Welcome to a discussion of the library match score outlier. The library match score is a comparison between the actual acquired spectra and a reference spectra. So a key step is to create the reference spectra. And I'll show you in a bit a couple of tools that will help you. Now please note that in Quant, we do not search library entries to find the best match. What we do is we compare the actual against a reference spectra. So that is not searching, that is really just matching with the dot product calculation of a spectra against a spectra. So there are library parameters which will affect the library match score. Let me go over a couple that will affect that. They are set at application initialization time, and one that does affect the score is the pure weight factor. A pure weight factor of 0 is defined as a reverse library match score, which means that only the ions in the reference spectra are considered. The opposite of that being a forward match score, where all of the ions in the acquired spectra are matched up with the reference. The pure weight factor is initialized as 0.7 in the application, and that's what's shipping. Let's look at retention time penalties. So another set of choices which can affect the library match score, this is turned off by default in reference spectral matching, is to penalize the score if the retention time from the expected is different from the actual. And you can see there's choices here in terms of how that penalty is applied. It could be absolute retention times, or it could be retention indices, and you would see in that case you'd have a retention time calibration file associated. A key ingredient is creating the reference library. So there are tools in the Quant method editor to help you create that reference library. One, for example, will look it up in an existing library, for example the NIST, and would look for the compound name or matching CAS number. Another mechanism demonstrated in a number of the workflows is using a data file and obtaining the reference spectra from a sample. Would work very well if you had the standards and you were doing calibration. There are other mechanisms to get spectra into the reference library. I'm here in the MassHunter Quant library editor, and as you can see here I've got the spectra, and I can edit the abundance values and mass values here with the spreadsheet. And so from a list spreadsheet I can copy and paste those entries into this table. Another mechanism worth noting is I can import those from a JCamp file. And last I'll mention that from Qual you can copy and paste spectra into the MassHunter library editor and create a reference library. Thanks for your attention.